Hello, in this video we'll be showing you how to code using the Classiq platform. We'll go over how to describe circuit constraints, call pre-built functions, and specify your desired output. Let's get started. The following video shows code from this version of the Classiq platform. Since the software is updated frequently, for this video and for those that follow, we'll be attaching companion files with code from the most updated version of Classiq. Here, we see a Grover's algorithm implemented in Visual Studios. When coding your quantum circuit, there are three main components to consider. There are the circuit constraints, the functional blocks, and the output. The circuit constraints define the limitations you wish to impose on the circuit, whether it be the circuit's depth, the number of available qubits, which we call circuit width, or the maximum number of times a specific gate can appear in your circuit. You can also choose to optimize your circuit according to one of these parameters. For example, let's remove the width constraint and instead set it as an optimization parameter. Now when the Classiq servers look for an appropriate circuit, it'll search until it finds one with the minimum number of qubits while still meeting our other constraints. Once you're done defining your constraints, it's time to design your quantum algorithm. You do this by calling a set of functions that functionally describe the quantum algorithm you wish to build. While you can define functions yourself within the Classiq platform, for this video we'll be using Classiq's built-in functions. When using built-in functions, make sure to review our online user guide, which will specify that function's unique syntax and available parameters. Here, we call the function Grover operator, and under function parameters, we specify the expression we want the Grover's algorithm oracle to solve for. The function Grover operator has parameters to define the number of qubits we wish to assign for each of the variables in our expression, as well as the uncomputation method for the circuit and other optional parameters not shown here. Last, we select our output preferences. You can select the output format of generated circuits and the list of available gates used during the circuit synthesis process. If no preference is selected, the default output is chasm code, and the default set of gates include all single qubit gates and the basic 2 qubit gates. To run this code in Visual Studios, run the command generate quantum circuit. Select an output file name and your circuit will be automatically synthesized. If you plan on using Classiq's Python SDK, the steps are largely the same. The model designer function is where you'll specify your circuit constraints and your desired output format and gate set. You'll then call various functions to outline the high-level model of your desired circuit, and at the end you specify how you'd like to represent your output, as an image, as an interactive circuit, or in your desired quantum programming language. We hope you found this video helpful. Thank you for joining us at Classiq.